All right, as Josh was just mentioning, we've wrapped up 2025. I'll spare you the review. We'll do it at another time, but do check out our prior recordings from these great talks from 2025. We've also had additional meetings as well. And of course, we have videos going back all the way to 2022. So please check those out. So today, we're going to talk about MCP. I've spent a fair bit of time actually trying to figure out what we're going to say in about 30 or 40 minutes. So, if you know MCP, please jump in if there's particulars that you think are worth mentioning. I'm going to start with a short presentation, but then I'm going to mainly get into demos to show you how the various tools are starting to actually implement MCP. So maybe something to consider is in short, MCP is not fully implemented basically anywhere at this point in time. Whether a client is missing some kind of authentication pass-through, or if there's the use of, I gotta admit somebody, there's the use of the LLM from the server side. We'll talk about that as well. That's not implemented, not even with Anthropic tooling. Sorry, I gotta admit somebody, but now I can't find the window to admit them. Why can't this just work? Yes, Google, I know somebody wants to join. All right. Very annoying. Okay. So what is MCP? All right, so Model Context Protocol. In short, as it says here, open source standard for connecting apps to external systems. There is a competing protocol that's at a high level. It's called A to A, agent to agent. And there's a variety of related protocols, but just to kind of set the stage, agent to agent is kind of in the name. It's meant to treat the other side, think server to server, as another self-functioning, reasoning agent. MCP is started off with, think of one agent actually having the ability to talk to your databases and opening files and writing files. In other words, things that don't have agentic capabilities, right? You're just standard tools and software that we've always had before AI. That's where MCP comes in. The reality, though, is the world is getting blurred a lot. It will hint on why that is as we proceed here. So the main components of MCP, this comes, not this graphic, but these items, components come from their website. So there's the specification itself. So what is the specification? The specification, in short, is enumerating the required functionality, what they call the must-have functionality of the MCP protocol. So that includes things like the behavior of the MCP client, the MCP host, the MPC server. What are they required to do? And that's at a wire level. So at the data wire level, there's the use of JSON RPC. So that's a particular format. There's a base version of that's required. So that's something to take note of. There is optionality to add different features to the payload itself with the different schema, and there are methods to specify that schema during your communications initiation process. So that's the kind of thing that you would find in the specification. Again, how do we talk to each other? There's not things, though, mind you, on how to find each other, like a registry. So that is a kind of an external effort that's being done that will eventually get rolled back into MCP probably at some point. The SDKs are frameworks to help us build these things called the MCP clients, the MCP servers, the MCP host code. And so again, this is to make it easy. So we don't need to necessarily worry about what is the initialization protocol? What kind of messages do we get? What kind of notifications can we get? What kind of errors can we get, right? We can do that by hand, and I'll show examples of how that's done in a minute. But again, these SDKs are pre-built by companies, so we don't have to. Again, as of today, nobody, at least of the major providers, and I'm picking on Anthropic, the people who release the MCP protocol, do not actually support the full MCP specification. So that's what that really means to you is it is early days, even today, right? This has been around for a year. Things are still moving fast, and we're still trying things out. So don't feel like you're left behind, right? It's still a good time to learn. It's still a good time to jump in. Then, of course, there's development tools and implementations to try out, and we'll see some of this. So here is the point of contention that I was mentioning earlier. Oh my gosh, Google, go away. All right, so what this is showing us is two different kind of styles of the MCP server. That's the part that you need to focus on here. So on the left-hand side here is the traditional kind of the last year, what MCP looks like to a typical consumer who writes code using this. And so what you see here is an application on the left, and embedded in it is some client to talk to an AI or mostly an LLM, and an MCP client, which will talk to an MCP server. Normally, according to the specification, it's one-to-one. One client talks to one MCP server. If there was a second MCP server, you would have a second client. There's for different reasons for that. Again, it's totally under your control. You can do whatever you want, but again, part of it is got to do with threading and parallelization and things like that. So it's just something to keep in mind. That stuff is still, optimization is still being worked out on. And so how does this kind of just work? Well, in its most basic level, it is just RPC. The client can say, hey, server, what tools do you expose? And what do they do, right? That's what we call the description. So all that information comes back. And then from that point, we give it to the application, what we call the MCP host. That's its kind of name in the MCP universe, is your app is called the MCP host. And you, based on your logic, will decide what tools will get passed through to the LLM. And then you ask the LLM, like, hey, here's my problem, like, here's my original prompt. And I want you to also consider running these tools. And so you send that to the LLM. The LLM will then pick one of the tools maybe and say, hey, you should run, that tool. And then that goes back to you, the MCP host. So it's still, the tool has not been executed yet. And so then the MCP client will then say, call this tool and send that request to the server. It will execute the tool and then send the results back. During this process, there could be several tools being executed. There may be no tools executed. That's part of the reasoning, what we call the action loop here. That's part of that reasoning cycle. That is a very ill-defined piece of the puzzle. Right now, most MCP anything do not actually have any kind of built-in action loop. You build that. And so there's a lot of reasons for that. It's one thing is like you just blindly execute things and hope it works. You still have to check the output. What does it mean that it actually works? Another thing is to have actual reasoning and logic to pick that. So that is a big hole in this whole specification. So it's something to consider. Now you take that and go to the right-hand side. The right-hand side here is similar, but notice the action loop has been moved to the server. This is a simplified view. What this is saying is instead of there being many tools directly accessible by the MCP client via the MCP server, what it's saying is I'm going to send a high-level request. Book me my flight, right? Then the logic is actually on the MCP server side, right? It'll be like, oh, I have to decide if I'm going to call all these different tools and use them to book this flight. All in the meantime, asking you if you agree to this or don't agree with this. So again, the reasoning, the activity will now be moved over to the MCP server. Now, could there be a world where there's logic on both sides? Yes. Again, this is a simplified view. So these are the kind of the two worlds we have. There's more traditional RPC client server side, and then there's this agentic style where you give it a high level description and it just does it. Now this is where it starts to get muddy, where it looks like A to A, right? So if you don't know what A to A is, don't worry about it. But if you do, you probably see some overlap here, and that's something to highlight. All right, so that session that we were talking about, you can kind of visualize it here on the right, what we were just describing. So we just kind of walk from top to bottom, right? That the MCP host is that kind of middle line. I don't know if I can, I guess I don't have a pointer here. Do I now? Is that middle line here, and you can see it says, hey, client, go get the tools. The server gets the request, sends back the list of tools. The host then can do some initial filtering, or it can just pass them through to the AI client, which then allows the LLM to select the tools. And so when I say select the tools, what am I actually meaning? It is just a simple list of JSON descriptions, the name of the tool, and that's about it. And the idea is the LLM will look at the descriptions, it will look at your prompt and say, hey, this tool looks like it'll solve your problem, right? So that's the kind of reasoning on the LLM side that's actually happening, right? That doesn't preclude you from doing reasoning, but that's where it does its reasoning, and it will pick one of the tools. Now, models have been built to kind of, or I shouldn't just say models, but the hosted versions of models have been kind of engineered to pick a tool. They're not usually going to return like, hey, run these 3 tools, right? But it can actually do that. So you could say, hey, give me a workflow and pick 3 of these 10 tools, right? And do it all in one go. So again, there's lots of reasons to do that. One is just performance, another is cost, right? All those kind of standard concerns apply here as well. So when we are actually implementing this, there's 2 ways to actually communicate between the MCP client and the MPC server. One is through standard IO. What that is a protocol independent of MCP, right? It's an old-timey protocol that was made for applications to talk through standard in and standard out, right? So that's a typical Unix thing, right? Why would you do that versus say a network-based approach, which is the kind of second approach? You do it. One is for performance, another is for security. A perfect example of an app that does this is Docker, right? Docker, when you install Docker out of the box, you get a Docker client and the Docker daemon. And when you say Docker run or Docker pull or Docker push out of the box, it's talking over a Unix socket, which is a file, which is doing standard IO, right? So even though it's HTTP, it's writing into a file, not doing it over TCP. So again, standard IO is more secure out of the box. Still not perfect, but more secure than versus a network and all of its related issues. We have the option to do batching of messages, and we also we have options for configurability around streaming, including potentially the use of SSE, which is a standard server-side event, so we can get messages back from the server, so like long polling in the old days, if you're familiar with that. And what this visualization is showing us is that the JSON RPC is just the message format. That's what gets sent over standard IO or over HTTP. Okay, so that's what you need to get out of this. It is schema managed. We're not going to go through all those details because we don't have time. It is just JSON. There's a schema if you choose to use it. It has a base requirement schema, even if you don't specify it. So those are things you would want to consider. Another thing to just mention here is streaming is preferred over batch in not just MCP, but in LLMs in general. And the reason is because it's just the nature of what they do, right? They generate a next token, right? So if they're generating, you could, in theory, buffer all those things and then kind of take a batch pull approach. But a more real-time experience, of course, would be through streaming. So that's just something to take note of. You may wonder why you see all this talk about HTTP streaming, and like that's because it's a reasonable approach for something that's dynamically taking time to generate its output. All right, excuse me. I have a demo I'm going to show of various configurations of MCP. Excuse me. Allergies are getting me down here in Florida. All right, let's take a look at the demo. Yeah, I'll try to show this side by side as best I can here. Okay, so the link will be put in Slack when I'm done here. Can you, everybody, just to confirm, can you see my screen? Should see VS Code.
We can see the slide about the CNCF AI TCG.
Ronald, I think you are on a mute. Yeah.
All right, hang tight. I have to restart Chrome because this is a brand new computer. Sorry, one
Oh,
second.
no issues. No issues.
Uh,
Ron, you're muted.
Thanks. How's that look?
We can see it now.
All right, sorry about that.
You can see that.
All right, so here we go. So what I'm going to do is show a couple of different configurations of things, just so you can kind of have an idea what it is you can do with MCP. So just a couple of things I'll just say, because we're running out of time, is I already set up Claude, so I have an Anthropic account. I already set up OpenAI, so I have an account there, right? So I have keys and things like that. So I'm not going to redo all that, but just something to keep in mind. So the first kind of demo we're going to do here is with K8sGPT. So if you're unfamiliar with K8sGPT, K8sGPT is a tool, one of the first tools and main tools to actually integrate the use of an LLM in the hopes of managing Kubernetes, right? So it's been around for a couple of years, and most recent release has included its first formal release of MCP capabilities. So it'll operate as an MCP server. And that's what I'm going to largely show you here. All right. So you can, there's different ways to run K8sGPT, but I'm going to take the easy route here. So K8sGPT, hopefully you can, maybe I should go the other way. So you can actually kind of read what's going on. All right, so what this is doing is it's K8sGPT serve. What it's basically doing is running it as a daemon outside of Kubernetes. So I've got Kubernetes running on Docker desktop here, and it's going to allow me to connect to it through curl and other tools, Claude desktop, things like that, and send these MCP requests, like list the tools, list the resources, right? Things like that. And so to turn on MCP in the latest version, you have to give this additional information. And here we're going to just use OpenAI as the model. So what can we do with this? So first, again, I'm just going to go through the script I made here. So the first one here is we're just going to list the available tools that K8sGPT is actually offering us, right? And so we could see that here. And so there's a bunch of things. I'm just going to pick this last one. So you can see here, here's one tool called remove filters. Now, this is a K8sGPT feature, but it's being exposed as an MCP operation. So what this means is it says it removes filters to disable specific filters. So for those who don't know K8sGPT, real quick, what is a filter? A filter represents a resource in Kubernetes. So like there's a pod filter, a network security, network policy filter. There's a deployment filter. And so what you can do is when you ask K8sGPT, like, hey, tell me, are my deployments good? You need to have the deployment filter enabled. You can disable it if you don't want to see it. So why would you care? Well, if you have 20 different filters, you're going to get a lot of different things being checked. If you just want to check one thing, like just pods, you can disable all the other filters and leave the pod filter enabled. So when you install K8sGPT, there's 10 filters out of the box, pods, deployment, services, things like that. So that's what this is telling us. We can actually remove it. So in other words, it reconfigures K8sGPT how it operates. All right, so that's an MCP call. All right, so again, just to highlight it because I went kind of quick there. You can see here, this is hitting K8sGPT's MCP endpoint. This is a good representation of a JSON RPC request. So what you don't see here is behind the scenes, there's K8sGPT is listening for these kinds of requests. But if you had an actual client, you would do an initialize and other kinds of statements as well for streaming and things like that. Okay, and there's the actual method. So that's an MCP formatted request. So give me the tools. Now you have to implement this. To be clear, there's no magic here. The MCP server, in this case, K8sGPT, has to actually implement this, the code to give us the list of things it can do. Okay. All right, let's take a look at another one. Next one is we're just going to call the analyze MCP command here. And what you can see, hopefully, is we are calling this generic endpoint called tools call. So that is the JSON RPC generic description to call some tool. Well, which tool? The tool is specified here in the parameter section. So this is all part of the schema of MCP. And so in this case, we're saying run the analyze tool, which was in that list of all the tools. We want to run it furthermore just on the kube system namespace and explain. Now, explain is a K8sGPT terminology. It means use AI to take the event stream from the namespace kube system and analyze it through AI. If you don't do that, you'll get an analysis that is not through AI, right? Through an LLM. You'll get an analysis that's based on just hard-coded things like, if I see an error, in the event stream, report that there's an error, but don't say anything else about it. But But here we're saying, go to, in our case, OpenAI, telling K8sGPT, go send all these things to OpenAI, give me the results. And that's what we see here. You can kind of see what it's saying. So it says, bad config map, right? It's not used by any pods, right? And then it gives us a natural language explanation. And again, that's because of K8sGPT, right? The MCP part, to be clear here, is simply just calling this tool that it exposed. From that point on, what it does, in this case, go get the event stream of this namespace and see if there's errors, send it to an LLM. That is all done by K8sGPT. So in that earlier diagram that we were talking about, like there's a client server kind of setup, or there's kind of a agentic way of doing it. This is kind of a mixture of both of those, right? And that's part of the complexity of these kinds of systems. So you can see there's all kinds of things, right? Another config map is not used. Another one's not used. Another one's not used, right? So apparently we need to clean up our config maps. And we can see it, right? We can say get config maps.
Uh, pause for me or for everyone?
Yeah, I think it's for everyone.
Yeah,
Yeah,
it's
I'm
person
not
for me
able
too.
to.
Let me message him.
Yeah, sure.
Okay, looks like he's rejoining. Maybe while we're waiting for Ron to rejoin, let's maybe do a quick round table around general issues with MCP. And I know many of us are sort of using it there in the field at the moment. Any key challenges or problems which anyone's sort of seeing with their usage of the protocol? I know
think
there's. Sorry, go
um
ahead. Go ahead.
sure. I use MCP, and at the same time I also build some of these agents. But one of the challenges is has to do with the standardization when it comes to the security part of it. Because right now, if you see when it comes to security, let's say authorization, authentication, right? There are not many options out there, and many people actually provide custom solutions when it comes to security on MCP. So I think it will be even good if we can have like a standard when it comes to this. Another thing is that when you are running many of these agents on a large scale, right? You need to start looking into mesh, just like you have for simple microservices architecture. And I think this is also like a challenge on how we can also integrate mesh into it without using vendor-based solutions for this.
That's a good call out. I know security is a topic which is top of mind for many, and I know Sadaruba, you're currently working on a paper within the CNCF community around addressing some of these topics. So it's certainly a lively problem space at the moment.
Yeah, that
Yes, we have started working on it. I think many of our members are here. Yushia is here. Shudhanshu is also here. So we are trying to possibly by the maybe towards March or April, we should have something for the draft on the white paper. So yeah.
Awesome. I've been wanting to join the sessions. It just somehow happens that customer meetings land on the exact time that they're scheduled. I've been struggling to actually make it. Yeah, it sounds like you guys are making good strides and progress there. So that's great.
Yeah,
Anything?
we had an unofficial meeting, so there were a lot of breaks. But from January, we're planning to start everything in proper order. So we have had 2 meetings, and we have assigned the tasks to different members. So we're just getting started.
Okay.
I'm sorry to ask, is there a way to also participate in this, or there's a different Slack channel or group for that?
We have a different dedicated Slack channel for this. Do you wish to join? We can add you there.
Yes, of course, sir.
Sure. I'll DM you the link and
All right.
So one topic on MCP while we're waiting for Ron to return. In terms of the number of tools which are allocated to a specific server, we're seeing a lot of vendors essentially just doing API slash. Okay, I can continue with that question another time. Ron, we were just doing a little bit of a round table around MCP while we were waiting for you. So the stage is yours again. So I'll let you jump back to it. And you're muted.
Sorry about that. I'm at Starbucks. Their internet kicked me off. Okay. So what I was doing, so I don't know where I got cut off, but we're at a point where it's okay because I'm starting a new demo. So what I'm doing here is showing how we can use Claude Desktop to interact with an MCP server. In this case, K8sGPT and a couple other custom built ones, just so you can see that it's possible. So Claude Desktop is for only certain computers. For example, it doesn't work on CISC-based computers. It works on ARM-based computers. It's actually why I bought this laptop, because I couldn't do things like this on my MacBook Intel. So now I got an M5, ARM processor, and now I can do things like this. So let me check. Can you see my screen? Full screen?
Yes, we do.
All right, thank you. All right.
yes.
So what we are doing here, and again, this will be shared, is start up Claude, and we would need to configure it. So it turns out Claude has a configuration file, and you can see it here just as an example. And what I've done here is basically say, hey, Claude, you can use these MCP servers. And notice these are all actually implemented via standard IO. Now, we just ran K8sGPT over the network as an example with using curl. Now, Claude Desktop is actually going to launch K8sGPT as a process and connect standard in and standard out. And that's the standard IO interface. And again, in theory, it's more secure and actually faster other than the start time. So those are things to consider. So what the file system MCP server is and what the everything MCP server is, I'll show that just as we go through here. Okay, these are just examples to show. All right, so how do you configure this? Once you've installed Docker or Claude Desktop, what you do is you go to connectors, manage connectors. And then you can see I've added these, but if you say, you go to developer, and then you go to edit config, that is that file, right? That's that file I was just showing you in the terminal. And so you would go here and it just opens the file. So again, that's where it is. And you can see right here, it's the same bit, okay? Now for security reasons, you have to actually exit Claude to reload these. You can't just edit it and then have it magically appear. And that's for security reasons. It turns out Claude actually has a bug currently. You actually cannot close Claude without force killing it because there's a bug as of the last 48 hours. That's what I get for using the latest latest version of it. Okay, so you can see here that file, once you've added that information, you can see they're listed here. Here's everything. Here's K8sGPT. Again, these are the prompts. These are the resources, right? So we could use these, but better, it is a client, right? There's a built-in MCP client to each of these inside of Claude Desktop, and it will use them, and we'll see how now. All right, so first we're going to look at the file system. So the file system one is a MCP server. In this case, we're going to launch it as a process, not as a daemon, and it gives you file system access to your local computer. So in this case, let me kick off. So we can watch this actually happening. Here's Claude's logs, MCP logs. And what we can do is, it says here, we can use the chat, list available routes. So if I come over here and say, so what is a route? This is a term used by the file system MCP server. It basically is a hard-coded URL or directory. It says you can look inside of here, and that's what it means. And so you can kind of see that here in the reasoning of Claude. It says the user wants to list available routes. Looks like they want to see what directories are available. Let me use the list allowed directories function from the file system MCP server. Now, how did it know that? So again, this is one of those things that is just ill-defined in MCP today. Right now, the host, in this case, the MCP host, which is Claude Desktop, went to all the different MCP servers and say, hey, what tools do you got, right? And what their descriptions are. And it uses that as part of its internal analysis on how it's going to do this. And so here it has permissions. We're going to skip that because we don't have time, but you just hit allow once. And so it's going to run this function, list allowed directories. And again, how does it do it? It does a call. It does a JSON RPC over standard IO. It says, hey, call this MCP server function, right? And if we go to the actual website, if I can find it, I guess I closed it. Anyway, if you go to the actual MCP website and look for extensions, you can find this file system extension and all the things it can do. And so here it didn't, right? So now if we take it one more step and actually say, list the files in desktop, right? So that's one of the allowed places. And again, that's configured in that JSON file. It's going to ask for permission to do it. You can deal with this, but I have it set up to always ask. You can see right here, list that directory. And there it is. And that's what I gave it permission to do. Now, if I say list/temp, something I didn't give a root access to, see what happens. It says you don't have permission. So that's good. Right? How much do we want to trust it? I don't know, but that's good. All right, moving on to the next example. So the everything extension is meant to implement all the endpoints of the MCP server. They don't necessarily do anything useful, but it's an example just so you can test the client. So in this case, they have a get sum as an example, right? So showing that we can do parameters, right? In this case, as a get sum, it'll add those parameters. So we come over here, I can say get sum 1, 2, and notice I just used the name of the function here. I didn't even allow it to think. I just said, you know, I'm going to call it and see if it can figure it out. Okay, so again, you can tell that it picked up the MCP server because it's asking for permission. In this case, it says use the add method from everything. And there it is. All right. So we could also just say add, again, using the descriptive term, not the actual function name, to see if it can deduce, it should use the everything sum function. And again, this may not work. It works most of the time, but because it's doing reasoning, it may not actually work. In this case, it looks like it's going to work. In fact, you can see here, used everything add function right there. So I knew it was going to work, but it may not work because it has to infer it. Okay, last example is going to be use K8sGPT. And so instead of, we turned off K8sGPT over here. Remember, we ran it like this manually as a server. Now we're not running it at all, but we configured it to launch it as a process and use standard IO. And so what can we do with that? Well, if we come here and we can say, actually, yeah, okay. So let me show you retrieval of a prompt, right? So if I go here to, sorry, it's from K8sGPT, I can say, give me the troubleshoot cluster prompt. Click on that, and there it is. So notice it's simply embedded in your current prompt. So if I add other information here, it would go with it too. But let's just let it roll. So if I'm going to go. Now this is a big thing. It's like, as it says, it's 40 lines. I mean, you could see here, it's doing a lot. It's going to go look at, do cluster type stuff. And then you can see here, it says, hey, you're trying to use K8sGPT, again, the MCP server. Here's the things I think you should be doing. I'm going to say, go ahead and do the whole workflow, which is all of this. One thing I don't like there is we have to like talk to it, right? I'd rather it just have a button that says yes or no. But again, that's Claude desktop's interface. All right, here it is. So it says, do you want to do cluster info? Again, remember that was one of those resources. So I'm going to say yes. Okay, do you want to list namespaces? And again, you see up here, there's that prompt. This is what it's trying to execute. Okay, that's continuing on. So again, this is step 2, which is this right here. Step 3, which is this. Notice it has an argument. We only want the 20 last lines of events. We don't want all of them. Now, this doesn't mean it's launching K8sGPT on each one of these. It launches it once, and it's using standard IO to go back and forth, right? You can kind of prove that if I just go back here and just try to run K8sGPT, it fails because it's by default has the port. Even though it's standard IO, it also does the port by default. So that's a bit of a red herring in there. Okay, check config. We're almost to the end. Oh, look at that. My one node cluster is good to go. Now remember earlier, it complained about the config maps. So again, we have to think of why that is. Well, that's got to do with how the prompt is done here versus what a normal analysis is done with K8sGPT. And that is the end of the demo, but I will add one last part just for those who are on the bleeding edge of MCP already. There's a feature I already mentioned, but I didn't give it a name, called elicitation. What this is the server may need help, but it doesn't have access to an LLM. So it can actually say, hey, client, can I use your LLM? You know, because on the host, you have access to an LLM. Can you go ask on my behalf to do something and give me the results? So that's what elicitation is. So to do it, you have to turn on a feature. The MCP feature is actually called sampling. And it turns out that Claude desktop doesn't currently offer sampling. That's why it doesn't work in this particular demo. That's it. Any questions?
So Ryan, I've got a question. In terms of the number of tools that you expose in a given MCP server, where do you see the sweet spot in terms of too many tools or too few tools to it? Well, maybe more too many tools when it comes to precision and the ability to execute at scale.
Yeah, great question. This is something I'll share in our chat as well. There is actually been a study, and I'm sure there's more than one, but there is a study that basically says you can have too many tools, and then so that's just something to consider per the question. And then the next thing is it's based on models. So apparently smaller models would require even a further reduction in tools. So like a 20 billion parameter model may handle 10 tools without losing its mind, right? And a 400 billion model may be able to handle up to like 30 tools before it loses its mind. If you try to give it 100 tools, and for those who may not know what we're saying, when you say as a client, hey, give me the list of all your tools, and say you downloaded 100 tools, right, that you could possibly use. You then take the 100 tools, don't do any filtering, send that all into the LLM and say, hey, LLM, here's my problem. Here's 100 tools to choose from. Which one should I choose from? When you have too many tools, it picks the wrong tool. And so again, these kind of prior studies have shown that a very large model could only use 30 tools range, right? Not even close to the 100. Again, and this will change per model. In the smaller model, the fewer the tools.
Got it. Thanks, Ryan.
I have one question around that feature that you talked about.
Mhm.
The last feature in the MCP where you give a sampling and all. So in Claude desktop, we cannot use it, but if we want to use it, how we would use it then?
Which feature? You mean the sampling?
Yeah, the sampling one, the
Yeah.
last one, elicitation one.
Yeah, so at a technical level, it's actually pretty straightforward, right? It's just bidirectional communication. So if you were going to implement it, you'd have to be able to have a long connection like SSE. This is where SSE comes in. And you would say, hey, I'm the server, I don't know enough. Let me send a JSON RPC message that says, I want to sample. And then you put in, what you basically prompt, right? You're the server. You send a prompt back to the client. You're like, hey man, can you go run this on my behalf, right? So in short, the only thing that changes here is it's both sides can use the AI instead of just client says, what tools do you got? Let me go ask my AI, get the results and send it, back to you to call whatever tools, and then get those results and send it back to the AI. Now it could have the opportunity to ask for help, mainly because the tools don't have any code, right? MCP servers don't have to have any code related to AI, right? But if you want to do a higher level agentic style server, you have to do that. Now, it turns out there are some examples that do sampling. So remember, the sampling feature has to be on the client side. I mean, they both have to do it. I mean, the server has to ask, but the main bulk of it is the client side. The client says, I'm listening for initial requests from the server of this form, and then managing that. So right now, far as I know, none of the major MCP SDKs support it. So right now, there's some third-party ones that do. They will support it because it is part of the specification now, but it's brand new. So it's going to be a little time before we can get out of the box. But for now, if you want it, you can either use one of those third-party clients to work with your server that will ask, or you would just build it yourself, unfortunately.
Okay. That's interesting. Yeah, I think that's a great feature. Yeah. Thanks.
Yeah. Okay. Any other questions?
I have a question. And let's say for example, when there is a token limitation on the LLM itself, right? And as you know, MCP itself basically, exacerbates the use of this token, right? So in a case whereby there's a limitation, what is going to be the impact on the MCP response?
Yeah, good question. MCP, as far as I am aware, knows nothing about things like token limits, right? If the AI just stops the response, it's on it to do the proper thing, right? So there is an error specification. We didn't see it. There is a JSON RPC error that if you're using MCP, you would return that. So in our case, remember the host app is actually two clients. There's the client to the AI, right? And then there's the MCP client talking to the MCP server. The termination of the tokens would be on the AI side. That actually has nothing to do with MCP. But the reality is services like OpenAI kind of influence this world. So when the LLM says, you get an error JSON payload, it looks very much like a JSON RPC payload. And so you can kind of treat it like you would an MCP response. But the reality is they're two totally different clients. So when we're talking about MCP, we're only talking about the MCP client. Whether or not the AI client does things like this, that connection between those two is completely on you. You have to, as the host application, you have to say, oh, I didn't get enough response, so I'm not going to pass it to the MCP client.
Yeah, I know that there are two different things because, the token itself is on the AI, which is the LLM itself, right? So what I'm talking about is like, how do we handle such cases?
Well, first off, you have to handle it. And so how might you handle it is, I think this actually has to do with that action loop that was kind of vaguely shown before. The action loop has to deal with all this kinds of scenarios today. The MCP specification doesn't say anything about it. So as far as, to be very clear, as far as MCP doing anything with AI errors, there's nothing in the specification, completely unrelated. So where you would deal with it, it would be in that action. And then in the action loop, you would say, all right, the LLM choked or stopped giving me tokens. You have to just write the code to deal with that, right? You have to decide, did I get enough back to actually warrant calling the MCP again, right? Through the client to do whatever it is you're doing again. There is no simple answer. The reality is that loop control is still completely ad hoc in today's world. Companies have how they do it. They have internal standards, but the reality is there is no standard.
All right, thank you.
All right. Sorry for all the AV net troubles. Thanks for hanging out, everyone, and Happy New Year's. This is going to be a great year. Josh, do you want to say anything to wrap it up?
Nothing else from my end, really. Just Happy New Year's, everyone.